Geometry Unit Section 1, Angles. People working in auto or ag mechanics, welding, engine machining, and so on frequently work with angles. An angle has two sides and a vertex or corner point where the two sides meet. The size of an angle depends on the amount of rotation between the two sides. If we have a full rotation, it's equivalent to 360 degrees. If you draw a circle and split it into equal parts, here we have a circle that has been split into 16 equal parts. If we continue that process until it is split into 360 equal parts, one of these parts is equal to 1 degree. So 1/360th of a circle is equivalent to 1 degree. It should take 360 of these sections to equal the 360 degrees. When we take measurements and we found that we're off by 1 degree, what does that really equate to? Well, it's dependent upon the amount of distance. If we have a length of 12 inches and we're off by 1 degree, it means we're off by a little over 2/10 of an inch. However, as that distance lengthens out, for example, if it's a 100-yard distance and our reading is off by 1 degree, that means the distance is 62.8 degree in error. Further out, if we have a 1 degree error and our distance is over 1 mile, we're talking about 92.2 feet measurement error. Angles can be labeled to help identify them. This is important when the angle is part of a more complex diagram. If we're going to label angle A, we can use a one-letter system. The above angle can be called angle A. This is okay when there's no possibility that the angle can be mistaken for another angle. You can also use a three-letter system. So we have angle BAC as a way of identifying this angle A. Equally, we can label it with CAB. It's as good and considered equivalent. The vertex letter, which is A, must always be in the middle. You can also identify the angle by its size, and in this case we have angle 36 degrees. In a more complex figure, when they're asking us to identify angle A, are they talking this angle A? Are they talking this angle A? Or are they talking about this angle? So you can see the importance of using the three-letter system when the figure is more complex. There are different types of angles that have specific names. A right angle has a measure of 90 degrees. Right angles are typically identified by placing a small box at the vertex. This indicates that the angle is a right angle or equals 90 degrees. If we have angles whose measure is greater than 0 degrees but less than 90, we call these acute angles. And here we have two acute angles can be formed by cutting the 90-degree angle. If we take those two acute angles, which are identified as angle A and angle B, add them together to equal that right angle, or 90 degrees, we have a name for that, which is complementary angles. A straight angle is a straight line. It has a measurement of 180 degrees. If we have an angle which has a measure that is greater than 90 degrees but less than 180 degrees, we call this an obtuse angle. And if we take the obtuse angle A and the acute angle, which we're going to name B in this figure, add those two angles together to equal the original straight angle, or a measure of 180 degrees, we have a title for that. The name is supplemental or supplementary angles. You're now ready to try some practice on identifying angles in practice set 1, found on page 4.